Hi everyone, welcome to lecture of probability. And my name is Ramazan, and I will give you some quick introduction in our first lecture, and we call it the probabilistic models. So when I say the probability, actually we are talking about some uncertainties. So we have to deal with some uncertain things in real life. We can give some different examples for the uncertainties. For example, imagine a student, she or he preparing for the final exam. So she or he has to deal with some uncertainty about the question, right? So imagine yourself, you are preparing for the final exam, but you don't know which questions will be asked. So what did you do in this situation? So probably you will check the previous lectures, and you will try to figure out which questions the lecturer gives some emphasis. Okay, so and then you can think that the questions will be asked from that path. So another examples can be from the stock market investors. So let's say you are an investor and you make some investments. I mean, you have some money, but you have to deal with some uncertainties. These uncertainties can be the future balance sheet, business agreements of the company, speculations, etc. And if you can deal with these uncertain things, you can make a good investment, right? Hi everyone, welcome to probability lecture. And in this lecture, we are gonna learn the basics of the probability models, and I will give you some quick introduction. And so the first, I want to start with some basic things like why do we need to use the probability? So as you guess, we have to deal with some uncertain things in the real life, right? And we can give some examples. Like, imagine yourself, you are preparing for a final exam, and you have to deal with some uncertainties about the questions, right? The questions will be asking the final exam. So probably you will not be sure about the questions, and you have to follow some strategies to be sure, or to guess what questions can be asked, right? So what you can do in this case, you will look at the lecture notes or the lecture videos, and you are gonna look at the what is the emphasizes made by the lecturer, made by more during the class, right? So and then you can think that the questions can come from this part, okay, and you will focus more on that part. So this is a kind of uncertain things, and you have to deal with, and all of the students will face this kind of uncertain things. So another thing is that, let's say you are an investor, the stock market investor, and you have some money. So you want to make more money, right, by investing some companies. And again, you have to deal with some uncertainties. What can be uncertainty in this case? For example, the future balance sheet, and let's say how change the company's income or debt. So another thing is the business agreement of the company, and another thing such as speculations on the market. So you have to deal with these uncertain things to make money. So another examples can be the manufacturer, let's say you are a manufacturer and you have to design and create a new product. And in this case, the uncertain things can be demand, right? Demand for a new product to be introduced to the market. So you don't know what will be the demand, and you have to shape your organization based on the demand forecasting, right? So this is a kind of uncertain things. So that's why we can say that when we say the probabilities, we are saying that we have to deal with that uncertain things. So we actually we want to learn some information to make more accurate decisions. In during this process, we are going to use some probabilities or some probability models. So the second question is, where can the probability be used? So probably in anywhere. Again, there is an uncertain things in the sentence or in these questions, because we cannot be sure or we cannot say that the probability will be used in anywhere. So it's not possible to say these things, right? But we can say it probably in anywhere because there are some uncertain things. So, but we can distinguish a situation. Let's say if there is a certain things, there is no need to use the probability. But if there are some uncertain things, we can use the probabilities. So let's say you are going to solve a math problem. So you know the formulations or other things, so you can solve this problem, right? So you don't have to calculate any probability of something. But if there are some uncertain things, if some things is not certain, in this case, you have to use some probabilities because you have to calculate some probability. So that's why if there are some uncertain things, we can say that we might use some probabilistic model or some probability things. So when can the probability be used? So our answer will be same, right? So if there are some uncertain things, we are going to use the probability. So especially when faced with a decision-making situation, you have to, or you need to use some probability concept, right? So the important things in this lecture at the end of the day, so will be uncertain things. So if you need to deal with some uncertain things, that means you are going to use some probability models. So when we work with the probability, so we have to use some set operations. So that's why we have to know some terminologies to be sure or to make it more concrete, that concept. So when I say a set, you need to think about a collection of the objects, and these objects are the elements of the set. Okay, and if we define the set as if we define the set as S, and this is a set, and X is an element of S, so it's a member of S, and we write it X in S. Okay, so that's mean X is element of S. So this is a simple things, but I just want to be sure that there's all these things needs to be more concrete. Okay, so on the contrary, if X is not an element of S, okay, we write it as X not in S. So a set can have no elements. Okay, there's no objects in the S. So in which case this is called the empty set, and we denote it by this sign. Okay, so you have to remember all these notations. So we can create or we can determine the sets in a variety of the ways. So if S contains a finite number of elements, right? X1, X2 until Xn, we write it as a list of the element in braces, like this one. Okay, this is our set. Okay, so let me write it more in a better way. So these are the elements and this is the set. Okay, this is the set. So there is something wrong in my pen. Okay, this is the S. This is the set, and these are the elements. And we have to, or we will do some operations, which is related with the sets. Okay. So, and let's continue with the terminologies. If S contains infinitely many elements, like x1, x2 until some points, and which can be enumerated. So we can give some, or we can create a list, like, let's say this is our set S, okay? And these are x1, this is an x2, x3, and it's going some points, but we don't know because it's an infinite, right? So, and I can give some number. This is the first element, this is the second element, and this is the third element. It's going infinitely. So we can, in this case, we can say that this set, this S, is countably infinite. Okay, we can count them, but it's an infinite set. For example, the set of even integers can be written as 0, 2, -2, 4, -4, etc. And this is a set, the countably infinite set. Okay. And in future lectures, we will look at the uncountable infinite sets. Okay, this is another story. So sets can be specified again, I think. So there is a mistake here. No, so okay, if S contains a finite number of elements, so we know that the cardinality of the set. So in this case, we can write the set as x, x1, x2, etc. until xn. So we know that the magnitude of this set. Okay, we can count the number of elements in the sets. Also, we can consider the set of all x, so the members that have a certain property p. That's mean this x's are created based on some conditions, right? So, and we can denote or we can illustrate this x as this sign x is such that x satisfies p. Okay, so this x is coming from these conditions. Okay, so for example, the set of even integers can be written as k such that k divided by 2 is integer. If this can be divided by the 2 and if the result is integer, I can say that the key is even number. So I can create the set like that. So this is the end of the part 1, and I will continue with a problem to introduce some other notations, and then we will continue. So these notations on terminologies is not limited to what I explained, but it's more than this. But as I said, as we proceed, we will look at some other terminologies. And the first thing we will look at this problem, and then we will continue with the sample space omega and the probability law. So please, please, if you understand, if you didn't understand some point of this part, please go back and recheck yourself. Okay, please visit the slides and the videos to completely understand what I talk about here. Okay, thank you.